So open up your own, if you don't have your computers in this room. What I want you to do is, those who haven't started the assignment at all, download the Excel file, which is in the question, where you know where the question is, right? If you go to the question, trying to figure out what's happening with this. Again, it's not turning on.
Yeah.
Once you have that Excel downloaded, which is the demand spreadsheet, yeah, enter your student number, open a blank Excel, another blank Excel file, yeah, and with your student number entered, copy that data into the blank Excel. Also, simultaneously download the PDF, which is called Diesel generator echo. About that?
You want to change the X axis, right? Escape. Cancel.
I can't remember
Once you click on the X
something.
axis, go to format axis.
Regular books.
You can change it. What do you have?
Oh,
AM. There should be unit here somewhere.
no, I think you can right. Why make? I mean, you got two like art star. Or then you should buy the. Huh? Oh, then you got download the software like Premiere Pro. What's it called?
So don't
After Effects.
AM, rather just do it 24 hours.
Actually, they got.
Don't do AM. In Excel, Excel confuses itself with the numbers. It doesn't understand AutoCAD. Even if you put the
I think Adobe, they give Adobe.
I will go.
Then I remember Photoshop all this, I think I got download. But if you want to buy the license,
That's good.
you can buy from Shopee, just buy the license. I think it's like
Somebody has
10 or $15. It's not because if you buy the original, it's the official one. That one is like a one-time lifetime. But I don't know is it real or fake lah. You can use lah. Last time I also wanted to learn the After Effects. I download already. Then never touch. Actually, you can just take the course. But for people,
If it works on one, then I would.
Middle of January. Actually,
last time I wanted to like consider this or the the game design. I think there's one school, Beach Institute. Wanted to go there also. I wanted to go into, but end up choosing this. Oh, there is concept art. I don't think you want concept art. It's like digital art.
Editing software, 3D animation.
Link to the source. Can you make a source this one? Also maybe in the
I want to finish.
maybe let's start. Maybe the third one. No, maybe the one underneath, second.
I forgot to do the graph already.
So just something is wrong.
Horizontal. Should be, it should be Y.
Let me see this one. Then you change.
I don't have this building again. Okay, there we go.
Go back. Format space. go back now to the senses and see. I tried something and it's working.
Strange.
Hmm? Oh yeah, it's correct lah. You just change the chart type. You go insert, I think. No, you just double click this, then forward. Chart design, sorry. Change chart. Then go to scatter. Then go to the other one. The one with the dot. Then you press OK. Sometimes one don't reflect. Don't make you reflect.
Who's the tallest here? Can you reach and it's not turning on, it's just going on standby.
You use the repeating method, is it not?
You can you read that?
Can consider repeating because the repeating one they never sort. I sort it out.
Just standby. If you can't, don't worry, then we'll stand
The
by.
other method I cannot get it to do.
I tried.
Okay, have you copied that Excel into a blank Excel? Everyone. Those who are, you can continue. For those who have just started the assignment, I'm going to help you. You have to speed up and come with, basically, catch up with others. Okay? So, there should be columns which say kW, kilowatts, in the heading. And there should be some columns that are saying kilograms per minute. Hot water, right? So these columns, they are kWs, 2, 3, and 4. Okay? So put your student number, copy this into a brand new Excel. Have you done that, everyone? No, do that. Some of you haven't done it. Do that. It shouldn't take more than a few seconds really to copy and paste it in another Excel. Paste it as value. Then add all the kWs in the last column. And then the next column, add all the mass flow rates. So that one and that one. I'm going to do that and show you. I'm just putting some random student number 99. So I'm going to copy this. Okay, watch what I'm doing. That plus that, that, that. Yeah, everyone done that? Now, after that, what we need to figure out in there was the peak electrical. So in this case, the peak electrical is 20.663. Oh no, sorry, 20.78 for that case. Okay. Now, based on that, the tentative generator will be, if we go to generator catalog, which one of those generators we are going to use for 20.78, not definitely not 12, not 14, not 16, 18, 21. I'll say this is our tentative generator, tentative for now, okay? It might be a final one, but there are a few more checks that we need to do. So we'll select that. Now we continue back to the Excel. Everyone clear up to that point?
Select the maximum, right?
Yeah, select the maximum. Select the maximum. But this is a tentative.
Yeah.
Good. Now going back, what we do now here is we say total heating demand in kilowatts. Now, how do you convert that? You write m dot Cp delta T. Basically. M dot from the previous column, but you have to write it in kilograms per second. Right now it's in kilograms per minute, convert it to kilograms per second. Then Cp of water, because we are heating up water. You can assume 4.18, 4.19, 4.2, whatever you want. But make sure you're writing assumption. You're saying, assuming Cp of water to be 4.2, 4.18, or 4.17, 4.19, whatever. And you want to heat up water from, if you look at the question, open the question. You want to heat water from 20 degrees to 85 degrees. So to 85 degrees. Okay? And if that's also clear in the schematic, if you look at the schematic there, we want to heat from 20 to maximum 85. So that delta T is 85 minus 20. Is that clear? Okay, do that. Excel. Don't wait for, don't plan to do it at home. Let's use this time and get the Excel done. Anyone who is gone beyond and you have questions, please raise your hand and come and help, because I think others are going to take time. Yes. That's what we need to find the one meeting. That column key up front. That's good. Yes. Yes. And also need to figure out a few more things. So, one more point. Is everyone okay with that equation? M dot, which is, we use that kilograms per minute, divided by 60 in a bracket, multiply by 4.18 or 4.2 Cp times 85 minus 20. Yes? Okay, I'll just enter, and should be somewhere between 18 to 27 or 28, depending on your student numbers. Pardon me? Using? That one. Yeah, it's using kilogram per second, yes. I've converted that in here in bracket, divided by 60 there. Which is that value kilograms per minute divided by 60. Yeah? Good.
The unit is kilowatt. Kilowatt.
Sorry. Kilowatt, that's correct. Unit is kilowatt. The reason that is in kilojoules per kilogram Celsius or degree Kelvin, and that's Celsius, they cancel, you get kilojoules per second, which is kilowatt. Okay, everyone up to there? Now, in the same Excel, we have to make one more tab, or we can continue going on that side. But I think that's going to get a little bit trickier. So what I might do, I might make one more tab, for instance. So I want every one of you to open new tab. Okay. Now I'm going to copy information from the catalog. So what model we have selected? We have selected 21 for the numbers I had. But whatever you're selecting, you have to get the information for your model, not my model. Okay. Now what information we need to pick is these columns. Also that column to begin with. Okay. So let's try to get, for my model it's 21. I'm going to say at 110% load my fuel consumption is 8.4, 100 7.6 and so on. But I'm going to create, I'll show you how I'm going to write that up. For a second. Okay, watch at the screen what I'm trying to do. I'm just trying to make it centered, just to look it clear, nice, neat. 110%, 100%, 75%, 50%. Okay. Now I'm going to say here fuel consumption, and I'm going to read at 110% for 21 was 8.4, 8.4 for 100% was 7.6 and so on. So you read your own model values. Okay, can anyone tell me where I got these numbers from? Anyone who is in doubt? Anyone doesn't know where I got these numbers from? Lost? Anyone else lost? You're lost? Okay, so for your model, you select these numbers. Now, what we need to do, I'm going to also select heat in coolant. I'm just trying to make it smaller, like heat in coolant, and that's in kilowatts. What else? Kilowatt. And then we have got exhaust flow rate. And then we have radiation heat loss. And I'm going to show you where I'm getting these from. So going back there, that's my heat rejected in coolant, that column. Cooling system, heat rejected to the engine coolant. Radiation heat loss and exhaust flow rate. Make sure you're picking up the right units. What are there? So that's in meter cubes per minute. That's in kilowatts. That's in kilowatts. Okay. Now what I'm going to do for my model, which was I think that one, I'm going to at 100% load. These are at 100% load. 100% load. 100% load. We don't know how the exhaust flow rate is going to be at 75, 50, or 110. What we are doing in that tab is trying to figure out how they are going to vary. Okay? So, I'm going to write in that table at 100% load. This is for model 21 kW. Okay, let me just copy that model exact number. Yeah, for that model. At 100% load, coolant is 24 kilowatts. That's in meter cube per minute. Is 5.4, and radiation is 10.6. kilowatts. Okay, now how are we going to find the rest? Because at different loads we need to find the rest. Is everyone up to that? Everyone. I can see there's a couple of students. Are you up to that? For your model?
Proportional.
Yeah, proportional. Proportional to fuel. Okay? Because all of these are relative to the amount of fuel that is getting consumed. Okay? Proportional to the fuel. So, what we are going to do there, equal to that multiplied by that divided by that. I will just show you one example for 110. 110%. At 110%, it's 8.4. That's unknown. At 100% is 7.6, and that is, I think, 24, if I'm not wrong. Yeah. So what we're trying to do, we are saying basically multiply that 24 divided by that will give us that unknown. Yeah? Okay. Everyone with me?
Yes.
So can you apply the same logic for the rest? I think if I will it work? No, it won't work. So I'll have to, let's see. No, it won't work. That needs to be that all the time. No? Okay. And that needs to be, let me rewrite it, sorry.
You need to put the dollar sign
And, dollar sign for,
to lock it.
yeah. What do we need to lock? We
C5.
need to lock that and that.
Yes,
So we need to lock D5 and C5.
that's right.
Okay, can you fill the rest of the table? Exact same logic.
Same logic.
Same logic for the rest. Exhaust, flow rate, and radiation. Okay, everyone with me up to there? Everyone is finished? Now what we need to do, right here we'll convert cubic meters per minute to kilograms per minute. Okay, let's convert that to kilograms per minute because what we need is mass flow rate. Now, if we go back to the catalog, this exhaust gas coming out of the engine is at what temperature? 455 degrees Celsius. It's not at ambient temperature. So we need to, when you want to convert mass volume flow rate to mass flow rate, you want to convert meter cubes per minute to kilograms per second. First thing is divide that by 60 to make it second, but then multiply that. So we divide that by 60, multiply that with density rho of air. At what temperature? At 455 degrees Celsius. How would you calculate that? Let's make an assumption in this case. In the question as well, it says assume air exhaust gas to be ideal and behaving like air. Because we don't know the exact properties in this case of exhaust gas. In the real world, you will use a gas analyzer, find out how much carbon dioxide, how much nitrous oxide and all of that stuff in the exhaust and predict and then estimate the exact values. In this case, we say it's an ideal gas and it's air basically. So we will use PV equals MRT. Rearranging this, what we want to find density. What's the unit of density? Can anyone tell me unit of density? kg per meter cube. Someone said that, I could hear. Someone said that. So in this case, that is meter cube. That is kg. So move that volume there, and that becomes your density. You want to find density, right? So you rewrite that equation: density equals pressure divided by RT. How much is the pressure? If you go back to the question, dead state pressure is given. What's the pressure here? Or here? 100, yes. 100, was it 0.2? Oh, yeah.
0.3.
Yeah, 100.3 or whatever that question is.
kp.
Yeah, kp. I think it says up there somewhere, right? Or, here. 100.3 kp. Okay? So, there, at the outlet here is 100.3, but we are trying to estimate all the pressure there. Now, one more thing you have to note. There's one more clause which says the pressure drop in here is negligible in the heat exchanger. I will show you where it says. Okay. Further, assume engine coolant, exhaust gas, and the water experiences negligible pressure losses. And that's why we are saying pressure before the heat exchanger is also pressure here is same as pressure there. That's the reason, that's the logic. Okay? Real world, no. Real world pressure here should be higher if mass has to flow in that direction. But we are saying it's almost negligible. It's a little bit higher, but we can ignore it. That's what we are saying. We are simplifying. Real world don't simplify. For first iteration, like if you're doing a preliminary study, yes, simplify things. But once you get, usually the way these things works in real life, a client approaches your company and your boss assigns you on that job. Client hasn't committed any money, but client just wants to explore whether it's possible. What's the potential? Now, there's no money, but you have to give some numbers to the client to make them convince, and they can give you maybe $100,000 or $1 million to do the detailed study. So the preliminary study, you spend maybe 4 hours or 5 hours, you have half a day worth of, your boss would say, okay, finish in half a day and give it back to me. You do some quick calculations, make some assumptions. It's reasonably, yeah, we can achieve something. And you go give it to the client, client signs a contract, and now you spend maybe a month on doing detail. And that's where you don't make these assumptions. You go and actually estimate how much will be the pressure loss. Consider everything, because you're getting a month's salary for doing that. Okay? So, hence, here's my Excel. Now, I'm going to copy that, paste it there, and that goes to kg per second. Okay? Now, how are we going to convert? We have pressure, we are going to use gas constant of air, which is R for air, 0.287 kilojoules per kilogram Kelvin. Temperature in Kelvin, so we will say 455 plus 273. And pressure in kPa, 100 kPa. So we know from there, so in that equation, in there we need to put this equation, divide that by 60, multiply the whole thing by values in that column. So let's do that. Everyone equal to bracket, one more bracket, 100.3 divided by 0.287 times bracket 455 plus 273. Bracket closed. One more bracket closed. One more bracket closed. Times not that, sorry. Times that, and divide the whole thing by 60. I think one more bracket closed. Okay? Yeah.
I missed out on how do you get the previous 3 rows.
That one or that one? All of them. So here we do the ratio basically. So that cell is an unknown. We know for 100% load how much is the fuel consumption, how much is the coolant heat. For 110% we know the fuel consumption. So we say that multiplied by that divided by that. Clear? Yeah.
Not possible to just multiply by 110%.
A very good question. Thanks for asking that. Can we just multiply it with 110% or 100% or 75%? Better not, because fuel consumption values are different. Okay? So that is load, 110% of the load. Let me escape. What is load? So there, 21 kW, that 110% of 21. So that is 20. Oh, hold on. Let me remove that kW from there. Just 21. That's the electric power in kW. So that is equal to 21 times 1.1. That is equal to 21 times 0.75 equal to 21 times 0.5. Okay, your question for power, you can do just multiply it with 1.1 or 0.75 or 0.5 for electrical power, because that ratio is for the load. Now imagine you design an engine. This is very important for everyone. You have designed an engine that is operating at an optimum performance when it's at that load, 21 kilowatts. When that engine is producing 21 kilowatt output, it has the peak efficiency, maximum efficiency. Now if you operate the same engine at any other condition, what's going to happen to the thermal efficiency? It's going to drop. If you go above 100%, thermal efficiency drops. If you operate it below 100%, thermal efficiency drops. What does that mean? It doesn't mean that it's not going to, engine will not produce power. It will produce power, but it will need extra fuel to produce the same amount of. So if you get 10% higher power, it doesn't mean you will need 10% higher fuel. You might need 20% higher fuel. Are you following me?
Yeah.
Because thermal efficiency is not constant. If we assume thermal efficiency constant, yes, that will be relative to the, but that's most of the machines, they don't work like that. They are designed for one operating point. Any other operating point, the efficiency drops. Make sense? Good. So once we have that, it will make your life a lot easier now. Let's write equation for, basically let's find a slope. So I'm going to do,
Can I take a peek at the formula again for exhaust flow rate, the last one?
there.
Yeah,
Okay.
I just want to see the
Yeah.
Is all the formulas the same ratio?
Oh, sorry. Can you see that there?
Yeah.
Yeah, what was?
Formulas the same ratio?
Yes. So relative to that, so for exhaust, instead of using 24, we are going to use 5.4. Yeah, and so on. Everyone with me? Now I'm going to draw a graph between that load and coolant. And I'm going to draw something similar with exhaust flow rate. I'm going to only show you these two. You can draw the something same similar graph for radiation afterwards. Okay. Now, for coolant, I'm going to select that line, right click, go to add trend line, and then go below and say display equation. I'll move that equation there. Basically what it's giving me equation of the line with the slope and everything in there. So if I tell how much percent load my engine is operating at, which is an X value, it will tell me how much is the coolant heat, Y value. Is everyone with me there? I can repeat it once more. I want everyone to focus. Okay, everyone focus again. Have you followed how I draw that graph? I've drawn the graph between this load, I've selected that and selected that. Gives me a graph. Up to that point, everyone is clear? Then I click on the curve, right click and say add trend line or trend line. And then in the trend line at the bottom, I say display equation, which displays that equation. What is that equation? Is the equation of this line. What is it trying to tell us? What's the value of y if x was some number? So if x was 40%, 60%, 80%, 100%, what's y? Although we do not have anything below 50%, we can assume it might discontinue. Right? If you get some numbers which are 45%, most likely you're not going to get, for all student combinations I've tried, it stays somewhere around 58% minimum and 100% maximum, within that range. Some maybe one or two student number might get 55, but still within the scope. Okay, everyone with me? Now, just follow what I'm going to do. I'm going to copy that equation. I will just use my keyboard, okay? I'm just going to do Control C, escape, go to the first tab, close that. Now, I'll leave one empty column just to make a difference, and we're going to say thermal energy okay. I'm going to for now just paste that in there, leave it there for a second. Everyone follow what I did so far? I've just left it there. I'm going to change that in a minute. You have a question? No. Now, in that empty column, what am I going to do? I'm going to figure out how much percent load do I have. So, in there, I'm going to say percentage load equal to where's my total? Where's the total electrical? Here. That number divided by the model I've selected, 100% is 21 kilowatts. Are you with me? And then I'm going to do that ratio multiply by 100. That's 89%. I'll just round it up. Oops.
So where does 21 come from?
Huh?
21.
Oh, the model I selected.
The model.
Your model is 21 kilowatt model.
Yeah.
Your model is maybe different.
Oh, okay. Based on that.
Yeah, your model. Because what we are doing a ratio. So for the generator that we have selected, how many percent is our demand for the peak value of that generator? Is that clear? What is that column to everyone? Yeah. Yeah. So for that equation you mean? Yeah, I'll come to that in a second. But is that clear? How I get different percentage load? Is it clear to everyone? Percentage load. Okay. Now, why is it important for us to figure out how much percentage load? That's in percentage. I'll just put a sign here. Is because if I go back there, what do we have here? Percentage load and how much heat is being rejected. So going back to this equation, did you follow how to draw the chart? Yeah? No? Okay. Chart is just I'm selecting load column and heat rejected in the coolant column. Right click or go to insert and scatter, and any one of these scatter, doesn't matter which one. Clear? Then you select that line. I'm going to do that for this anyway, I have to do that. So for exhaust, I've selected the line, right click, go to add trend line. Everyone has found that? When you click on that, you get this small window on the right hand side. Scroll down right to the bottom and say display equation on the chart. And that displays, if I close that again, it displays that equation which is for my exhaust. Is that clear to everyone? Yes? Yeah. Yeah. Oh, just one second. But is that clear how to get the equation?
Yes.
No doubts for anyone? Okay, so are you following what is meant by that equation? For how many percent, what for different percent loads, how much is the exhaust? For different percent load, how much is the coolant heat? Now going back to that tab, what I've done, I've used that column. I will just highlight that column for a second. So one of your classmates is asking. So that's our demand. That's our demand. The yellow column is demand. Now,
See the formula?
yeah.
No. How you get the difference?
Then that demand divided by what I've done is 21. Why 21? Because I've selected that diesel generator model for myself. Now your diesel generator might be different. So what is the peak? Which one have you selected? Oh, why? You have what's the peak demand? What's the peak in here for you? Can you tell me the number?
18.35.
Okay. So you cannot select 18 because it's more than 18. 18. So you go to 21. What's your peak?
14.35.
Peak electrical is 14 So you have to select 16.
Yes.
My peak is 12.5.
Can you repeat?
It is 12.5.
So you have to select 14. Not 12. What's your peak? 21. 18. Yes, at the back. Only 16.6. 18. Good. Clear? Logic to everyone? Okay, so now we are going to use that equation that we just copied from the Excel. I'm going to add equal to, and that x will be replaced by what? By percentage. That's it. Simple.
Is that the equation from which graph?
Huh?
That equation from which graph?
Coolant.
Electrical demand.
Coolant graph.
Oh.
Let me see. Let me just check one thing, because you have to be a little bit careful. You see, value of coolant heat rejected in kilowatts, maximum is 26 kilowatts, minimum is 13 kilowatts. So is that in percentage? So if I right click on there and go to format cell, it is in percentage.
Yes.
So what we need to do, going back here, I don't need to multiply that with 100.
No need.
No need to multiply with 100. Okay, please don't multiply it with 100. Rather, what you do,
Format cell.
format. So we go format cell and say percentage. Do you want me to repeat it? Okay. Not multiplied with 100. Everyone's getting. I haven't multiplied it with 100. It's just the ratio of peak. Is the ratio of the total power divided by the selected model number. And then I right click, format cell, and say percentage, and gives me percentage. Clear? Now, Oh,
I shouldn't have anything over 100%, right? The load.
no, if it's something more than 100%, you have to select the next generator. You have selected a wrong generator. Yeah.
Yeah, that means it's wrong. It's
Okay, pay attention. Once more, I'm going to show you how we get that formula. So I'm just going to delete the trend line.
say you can choose this one.
You know how to get the graph? Now you click on that graph curve, right click, add trend line. Or you're using Mac? I don't know. Is the same? Okay, good. Okay, and then if you go to the bottom, say display equation on the chart. Yeah. Yeah, sometimes this happens. With Mac, I don't know how things work. You have to ask your friend, but this one is simple. Okay, so everyone please pay attention, we are running out of time. We need to cover a lot, I want to solve one problem. So, I'm going to say here, equal to, and then replace that x with multiply by that. So I got that equation from the graph, that x which was here, I've replaced that x with multiply by my actual x, which is the load. X is the load, yes.
X is the percentage, right?
Yes, percentage, that's correct.
Correct.
So I get 21.7 kilowatts for the first, and then that's how it varies.
Yeah.
So that's the thermal energy available in the coolant. My demand is that. So that's not enough. That's not enough, definitely, because that's the demand and that's the supply. But this is only from the coolant. Now we need to figure out from the exhaust. Because we have heat from coolant and heat from exhaust.
Okay.
Together, whether it's enough or not, we need to figure that out. If it was enough, then our model is okay. And that was the second step, cross check. If the model is okay, I'm going to focus. No, that's the demand and that's supply. Supply is less than demand right now. Yeah. So let's go and do exact same, one more column and say mass flow of exhaust.
This one we need to
Yeah.
remove the.
And you know, we go back to the chart, copy that equation
Remove the
for exhaust equation, okay?
Okay.
And same logic.
Okay.
X is our percentage.
Yeah, right.
Oh, what happened? There's two equal to signs. Everyone with me? Lost? Where you are lost? I mean, you got that column? That one? You got the graphs? Okay. So, others, you continue. What I want you to do, others,
Yeah.
finish that,
Yeah.
and I want you to try the next column because it's your assignment. I'm not solving the whole assignment for you. Okay? So, in that column, you're going to find Q dot exhaust. Q dot exhaust, you're going to use M dot exhaust Cp delta T.
Q dot.
So, Q dot exhaust, M dot exhaust, Cp exhaust, delta T. Now, Cp exhaust is approximately equal to Cp air. Assume it to be equal to Cp air. Okay? Cp air is 1.005 kilojoules per kilogram. Okay? Go and find the entire column till I'll have one of your classmates.
Two for example. Yeah, mass flow for this is M dot. No, you cannot drag this one. You have to reselect the data. You right click here and reselect data. And this is the Y column. Oh, you yeah, you change Y. No, sorry.
Let's do
What is the one? Should be zero. Yeah, should be the same. Plus the same.
the way catalog is given actually. What's your model?
Oh, you still got one for radiation.
I know, that's what I think it's similar step. That's the first one.
The keyboard is different size. Okay? That's a very good question. That's what I'm waiting for the rest of the class. Equation you missed. So C is yeah, okay, yeah.
What's us to do Q?
Q divided by
Aviation but I think need
yeah, that's what logic is good.
All the way to follow
The same logic.
yeah.
Yes. You follow everything based on the Q. Clear. You want you to explain?
Exhaust flow.
Yes.
Oh, 005. Yeah, plus 273. Yeah. No, actually no need. Because it's delta key. Delta key is the difference. So if you plus already, you still minus a bit.
And then X
Yeah. But if you put also nothing wrong.
when X was
Yeah, I took got to go.
that's your X was your
Why cannot action there? Or not action there?
Why are there so many things? Yeah, you read everything in transfer. I think you follow that. Follow book? Yeah, I'm good. For mass flow rate, yes. Yes. And the X is positive.
So the different temperature is 455 minus 110.
Okay, so what is that delta T? What is that delta T? I will come to you in a second. 455 minus
110.
why 110?
Because it's the minimum temperature.
You cannot go any lower, otherwise you will make acid formation. Like nitrous oxide will mix with the water vapor, which is condensed, and you will get nitric acid, and that's going to corrode your heat exchanger. So it should not cool down below 110 as a rule of thumb. Okay? Clear? Yes. I'll just write that up and then I'll come to what. So
455.
So heat available in the exhaust, mass flow rate times Cp times 455 minus 110, and now we are going to say total thermal energy available in kilowatts equals that plus that. Oh.
So can show the formula for
Plus.
If you put iron first. Yeah, now go to the drum, the other drum. Is that what's that? Yeah, it's pull it or can you make one more of that? Pull it? Can we go back to the equation? Okay, good. And now can you go back to the other so yeah, remove that 100%. Double number one has to and then select that column. Select that column.
what's your
Yeah, but why is it you're putting complete equation. Got the graph? No, basically, you got the graph, then no, you need to be 60. No, you should still be straight line. There's something wrong. This is which model? 40. Technically, can you use $100 sign also for B47? Let's go. No, again. And then last one is 0.8. Okay, that's already. So basically on the first. Can you zoom in? Yeah, I'm starting for it.
You had selected because it's not a perfect straight line. There's some variation in the motion you want to do. Right click, select the line, right click, add print line, show the equation, okay, follow. Okay. You okay? I think you're helping. Good. Yeah, we need to. Yes. We have to be ready. Right click. Go to change the line. Go to scatter. Otherwise, this turns off and then. Okay, total thermal energy, everyone pay attention. That total thermal energy is just addition of energy available in coolant and in the exhaust. So this plus that. And then we compare that against our total demand. Okay? Now you see, maybe pay attention everyone here. And then I will come and help. Okay? So if you look at that, you can see that row 1, all good. Your supply is more than 35 than the demand. Row 2 though, your supply is lower than the demand. And continue. Now, what do you think? The model is suitable? Maybe not. Maybe not. You can't say completely no. Now, what we need to do, we are looking at thermal energy. Question is asking us to store hot water in a tank. That demand is fluctuating. So if we could store enough in the tank such that for that peak, if we can supply from the storage, we might have sufficient. So you remember from assignment 2, we looked at demand supply. So we had something like that, right? And that's your demand, but then your supply, let's say, was, let me use a different color. It's not there. I think I should have. That's your supply, let's say. So that part is oversupply. That part is undersupply. Now, what we need to do, we need to figure out how much should be our supply so that area blue is equal to area red.
Average.
So that's what we will do now. Now, what we have here is kilowatt. That's in kilowatt and kilowatt. We need to convert. In next two columns, we are going to say kilojoules, kilojoules. So that will give us the total energy we have every hour. We will do sum of that available, sum of demand, so sum of supply and sum of demand in kilojoules. What we want to make sure, your sum of supply is greater than your sum of demand in kilojoules. If it's greater, then we can make size the tank. We can say, okay, we store some of that when there is extra. You see here in the first row we have got extra thermal energy. Then in the third row we have got extra thermal energy. In the fourth row we have got extra. Fifth row, no. Sixth row there is plenty of extra. So all of those extras, we'll try to see whether can we store them, those extras in the tank in form of hot water, and use it whenever we need, whenever we don't have enough. Okay, so let's do that. Is everyone up to there, or should I wait? Maybe I can answer a few questions and everyone can make that column, please. Has everyone made that column? No? So go and make that column. Total. You done? So anyone who has done that, what I want you to do is make next two columns in kilojoules. You know how to convert kilowatts to kilojoules? That is kilowatt every hour. So you multiply for that hour 3600. Good. Do that. And first and then second and third somewhere else. No, that's not really. That's an exhaust. Exhaust flow rate. That's already divided by 60. What we have here, you divide that by 60. You get to be 50%. We don't need 50%. We only need kilograms. Let's do one more. Let's get select that norm. Go to the floor. Yeah, and say the select the entire column. Right click. And go to format and position. Now also find the change it So, seriously looking. And then do the grouping of that entire both the ones.
The flow rate doesn't look right. So can we go to your next the ground floor? There's a ground floor. Oh, you haven't done that. So select that now. Control. Draft. Yeah, I know. Oh, 155, 451. Still wrong, maybe. Double click. What is it? Yeah, that's wrong. You see, at 100% is 3.6, 110% is 7.9. That's pretty much. Let's do it fresh. So don't worry. That let's don't worry about anything. Concept is keep the same logic for us. Yes. And also our body, let the bottom be 47. Obvious. Also the next one.
selected. Okay, everyone, pay attention. In there, I'm going to say demand kilojoules times 3600 supply kilojoules 3600. Now I'm going to say here sum and sum, and my supply should be greater than my demand. Is that right? Is my supply greater than demand?
Yes.
So hooray, that is suitable
Yeah.
for everyone you're getting.
Yes.
So that's the correct generator you've selected. You don't need, so the generator is now fixed.
Oh, okay.
And now you can continue the rest of the calculations.
Oh, okay.
So we'll stop the assignment here. We'll solve one problem and we'll continue assignment tomorrow. Okay? That one? That one is that 26, that value multiplied by 3600, 3600. Yeah. Okay? I know you have already got into the rhythm of doing the assignment, but then we don't have rest of the night. If you're not working tomorrow, maybe go home, take a break, and then start continue whole night if you want to. I will give you some hints what you need to do next, okay? So that you can, if you want, you can continue. Everyone pay attention. Before we solve one problem, I will just tell you the steps beyond this, okay? Now the next step is, because everyone please pay attention. And if you want to record here, please feel free to record. Now, once we have fixed the generator, now what we need to figure out, if we go to the schematic, I'll show you schematic, hold on for a second. We need to figure out temperature there. So our next column will be T2. So in your Excel, next column is T2. How would you estimate T2? Maybe I'll write the equation as well. What do you know? Do you know the temperature at the inlet of water? Yes. Do you know the mass flow rate of water? Yes. You don't know that much, but what do you know amount of thermal energy available in the coolant? Only coolant, not the total. Just the coolant? Can you look at the column? Yes, you know. So Q dot coolant equals m dot water times Cp water times T2 minus T1. Do you know T1? Yes. Do you know T2? No, then we want to find T2. Cp of water? Yes. Mass flow rate of water? In kilograms per second. Kilograms per second. You have to convert that to kilograms per second. Yes. Do you know coolant? Q dot? Yes. So the only unknown is known, that's the unknown. Then, once you have done that, you know how much is the temperature here, T2. You know how much temperature you want to be there, 85. What we need to do next is Q dot absorbed by water in exhaust heat exchanger. That is nothing but m dot water times Cp water times T3 minus T2. Do you know T3? Yes. Do Do you know T2? Yes, by that step. You know Cp? Yes. You know mass flow rate? Yes. You find the amount of thermal energy that water is going to absorb from the exhaust. Why do we need that? We need to figure out what's the outlet temperature. So now we say the amount of thermal energy absorbed by water is also equal to, so that value, whatever you get there, must be equal to m dot exhaust. Do you know m dot exhaust already? Yes. Cp exhaust, which is Cp of air, times T inlet of the exhaust. So T exhaust in, which is 455, minus T exhaust out, which is the unknown. So you know that from that equation. You already found that. You know that as an assumption, and that's given 455. That's the unknown. Clear? Now, once you, so that's the next column for the exhaust temperature. Over there, what you need to make sure, that's maybe one more check for your generator. You want to make sure that temperature is never below 110. If the temperature was below 110 even for one row, go back and select a bigger generator. But if you have the Excel ready, it's just a matter of changing few things and it works by itself.
So can you repeat that? Why would we need to change our generator?
If the temperature of the exhaust there from that equation, if it was less than 110 degrees, only then we need to change. I'm hoping most likely it's not going to be, unless you make a mistake in calculation. So if you're getting less than 110, two possibilities. Most likely you have made a mistake in calculation, equation wrong, something wrong. Or originally you have selected a generator which was lower than the peak. If it was greater than the peak, it should be more than 110. And that will finish your step 2 basically. Almost step 2. If we go there, determine the temperature, done. Draw the graphs, you can draw the graphs, easy. I mean, yeah, I know graphs sometimes can be a little tricky, but the only thing which is remaining is the size of the tank. How much water you need to store. So what I want you to do is read that part from hot water storage tank must be a cylindrical, all of that, and maybe a little bit before that as well. Let me read that part as well, which was right at the beginning, using constant flow rate of water. Okay? So, what are you going to use in there? What mass flow rate are you going to use here? Average flow rate. Okay? Not individual flow rates. Average flow rate because of that clause. Does it make sense? And so you're going to use the same flow rate and you're going to do demand supply. So how much is demand? If I go back to the Excel, how much is your hot water demand? Your hot water demand is that in kilograms per minute. Your hot water supply will be the average of that. Average of that. You find the average. Okay? Here.
So this is all from step 2, right?
Yeah, it is still step 2. That's the average. So let's make it blue. Average of the water. Okay? And so imagine you've got this average in one more column. I can do that quickly if you let's do that. So water supply kilograms per minute. That's the supply and that's the demand. So if we say water supply minus demand, you see, there's positives are oversupply, negatives are undersupply. So you remember in assignment 2 you have done that, oversupply, undersupply, how much should be the storage. So you figure out from there how much should be the storage, but this is per minute. Remember that this is per minute. What you need to do is get this into that multiplied by 60. That gives you per hour. Okay, and so if we do some of these, some oversupply, some undersupply, what should be the sum? Can you tell me what will be the sum? Should be 0. It's a little bit over some of these. It's not exactly 0. Why is that? Is there something wrong in there? Is the average correct? Because if it's the average, it should be. I'm missing one. I'm missing that. That's it. So it should be 13 up to 13. It's almost 0. That is almost 0. Yeah, 10 to the power minus 13, which is, okay, I think it's just the Excel error. So we are getting a balance. So how much should be the storage? Either add all the negative values in an absolute term or add all the positive values. And that much should be a storage of the tank. That many kilograms of water. Okay? That many kilograms should be your storage. And for example, that plus that plus that plus that many kilograms of storage, so which is 100, 200, about 700-ish, and maybe 750 or 750-ish, because we are missing 15 there. So 750 liters for that volume, 0.7 cubic meters. Now you are going to size the tank. What should be the diameter, what should be the height of the tank? And that once you do the sizing of the tank, step 2 is done. Okay, and we'll start with step 3 tomorrow. So, how about before you come to tomorrow's class at 2 o'clock afternoon, you have morning free, work and finish step 2 and come with step 2 completed. At least try it with very few questions remaining. Yeah? Okay, so. Huh? That's the demand.
Oh.
Yeah. The total of the mass flow rate of water.
Okay.
Yeah, that's the demand, and supply is the average value is the supply. Because we don't want a complicated control system, hence we are buying a pump which will constantly supply a constant flow rate.
So just also, sorry, so the volume of tank is all the positive values?
All the negatives.
All the negatives?
Either of.
Oh, okay.
Because that graph,
Yeah.
oversupply, undersupply, basically red area and blue area should be equal.
Yes.
So
Yeah.
value is basically 7.4 minus 5.8. Then the
That minus other. Okay. Maybe I will quickly go one example. Okay. I want everyone to pay attention. Derivation. That's going to be very, very, very useful. So I'm using so many varies. So definitely for assessment 4 is very, 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 very useful. Okay. I mean, Raj must have gone through that already, but just in case. We have done that already. I mean, we have looked at that equation today. So I want to go through, yes, this one. This is the solution is there on canvas. Under week 10? Week 10 tutorial. Look at week 10 tutorial. Sorry, I'll go back in a second. Okay, let me show you where it is. Another thing, everyone pay attention. Today's notes and week 10 lectorial material from 7th of July. Okay, because some of you are asking me to, everything is in there. So if we go there, I've also added that in here as well. But week 10 tutorial material, basically the solution part goes through no, not week 10, sorry, week 11. My bad, it's week 11. Week 11 tutorial. Here. That's the one. So let's quickly go over there in here. So the question says derive relation for internal energy change as a gas that obeys van der Waals equation of state. Assume that in the range of interest CV varies according to relation CV equals C1 plus C2 times T, where C1 and C2 are constants. Now this equation will be given in the formula sheet. I've already uploaded the formula sheet under lectorial 7th of July under week 10 section. Okay, formula sheet is there. That equation is given in the formula sheet. What we need to do, we need to apply that CV equals C1 plus C2 T in there, and then that partial differential, we have to do it, apply partial differential for the van der Waals equation. Okay, and I'm going to quickly go through that. So that's the van der Waals equation. If you want to partially differentiate that equation, so dP with respect to temperature dt at constant volume, okay, so we're not taking total differential. You understand, I mean, maybe it has been a while since you studied maths, partial differential, but the logic behind that is there are derivatives, there are some properties which are dependent on multiple variables. Okay, not just single dependency. There are two properties that can change one property. Now, how do we estimate what's the effect of one of the properties? So let's say x is a function of a and b. We want to find what's the effect of a on x separately, and what's the effect of b on x. What we do, we say let's keep b constant and differentiate x with respect to a, and then next time we keep a constant and differentiate x with respect to b as two separate differentials. And there's a mathematical rule that having two partial differentials, you can combine them together to get a total differential. You can do that, and that's very important from optimization point. Okay, but I'm not teaching you maths, and so I'm not expecting anything more than what we are going to do now. So if we are doing partial differential, if V is constant, if we are keeping specific volume constant and we are taking a derivative, okay, it's not an integral. So derivative of constant is what? 0. So A is constant and V, we are saying partial differential with V constant, that term becomes 0. Now, first term we have got 1. So V is constant, but we are differentiating P with respect to T. So how would you differentiate P with respect to T? What will happen to that? What will happen to the T? Just disappear. Basically T becomes 1. So dt or dt for constant V will be nothing but R over V minus B. That's it. Is that clear to everyone? I've done it in, yeah, okay. Lost. So just that. Is that clear now? Because that is constant becomes 0. Differentiating with respect to T, that T becomes 1. And hence we get that. So what we are going to do, substitute that in place of that equation in here. And CV is substituted by that equation C1 plus C2 times T. Then what I've done for now, just to simplify the step, I've taken this square bracket, written square bracket. Now in place of that I'm putting that and then expanding it. Basically imagine that goes in there, multiply by T, so I get RT over V minus B minus RT over V minus B plus A over V squared. Okay? Now where am I getting all of that? Because I know P is that. With me? So I'm replacing P with that, the entire thing. And then simplifying that, they cancel, I end up with that. Basically that square bracket is only that much. Okay? So replacing CV with that equation, now we integrate. Integral of x is what? X square over 2. Integral of a constant is what? X. Constant times x. So that's constant. We are integrating with respect to t. That becomes so t2 minus t1. So c1 times t2 minus t1 plus c2 t square over 2. Basically t2 square minus t1 square over 2. Maybe now it's clear. And that's it. That's the derivation. So question might ask you to say, ask you to find change in enthalpy. And I will give you the enthalpy equation and Cp, equation for Cp. And in enthalpy equation that will be Tv over T, dV over dt for constant pressure. So you just rewrite. I might give you a simpler equation in one ruler to make it a lot easier. But I just want to get you logically thinking how we can derive this. And it won't be, so out of 100 marks for the last assessment, if I say, that will be maybe 10 or 15 marks. So, worst case worst, you don't get it. You still have a chance to get 85, right? But if you want to get very high marks, you should know. If you want high distinction, you should know that. Is that fair? If you are happy with credit, skip that part. And that's it. That's it for today, sir. So tomorrow, assignment 3, step 2 is completed before you come to the class. Yeah? Challenge for everyone. Try. Okay? Maybe have 2 or 3 cups of coffee wake up and start working whole month. Do you have a group, kind of online group where you chat with each other? Yeah. So maybe just eat each other's brains at night like zombies. Okay. Sure. Maybe sit down. I'll just start packing up and if you can help record the
Now we have this multiply to number this maybe, right?
No. Seconds in an hour.
Alright.